When do you start? Turn on 你的 title 是错的。Never mind 啦，我手动改一下。这个没有办法。关门了。Yeah. Okay. Okay. Let's start now. Okay, hello everyone. Did we start now? Let me wait for 1 minute for everyone to join. What about WeChat group? Okay, WeChat is on. What about YouTube? I should open a YouTube channel to see your chat box. Okay, hello. Yeah, we start now. So yeah, for now, we have collected 18 questions. So there are 2 questions missing. So if you happen to remember the last 2 questions, not the last 2, I feel I get the question 19 and question 20 quite well. So maybe, yeah, if you have some question that I never mentioned here, so you can show me and I will run through it directly, okay? So now, yeah, the question is not at the order like you do it, okay? So sorry, I should mute myself. So this order is the order I collect the questions. So sorry, so you may see, so for example, this one must be some question 12 or 13 or something, right? So, but yeah, just show it in the order I collected. So never mind. So now the first question, yeah, it's something like a magic cube, right? So we should fill in 1 to 5 inside it. And so each row, each column is 1 to 5 each one. And the sum of each zone, they are the same. So maybe we first calculate the sum of each zone, which is, so the total sum for one row is 1 to 5, 15, 5 rows, right? And we divided it into 3 zones. So each zone have a sum of 25. Okay. So now, then we know each zone is 25. Maybe we only know one number 3 here. The 3 is so small. I write it larger. So 3 here, right? So maybe, right? So we should try to fill in the left down corner first to make it a 25. So notice that because on each row and each column, so there must be, right? So there must be 1, 2, 3, 4, 5 each ones. So maybe you feel the largest number ever because 25 is quite large. So we can put a 4 here, 5 here, 4 here, 5 here. So let's see what's the remaining. So 3, 4, 5, 12. 12 plus a 9 is 21. So meaning that the remaining zone can only be a 4, right? So now we would see if we want to make a 25 at the left corner, so it can only be 1, 3, 2, 5, and 3, 4s. It cannot be no more 5s. So, but this 3, 4 cannot be written here. So this 3, 4 must be written in this order. So it's 4, 4, 4, 5, 5. You see, now this is the only way we fill the left down corner. Okay with it? Then we continue, right? So we know 25 is quite large for a 6-number corner, but for the middle zone, right, there are so many grids out here. So 25 should make so large for the mid zone. So for the mid zone, we should fill as small number as possible. So maybe try fill 1, 2. So here is a 1, 2, 3. Here is a 1, 2, 3. And here is a 1, 2, 3. So let's see. After filling with 1, 2, and 3, 1, 2, 3s, how many do we remaining? This is 3, and this is 18, so it's 21. So 4 is remaining. So in this grid, the sum is 4, so it can only be 1 and 3, right? So then, yeah, we should know that in the middle zone, they are all 1s, 2s, and 3s. So together, we used up all the 5 1s, 4 2s, and 4 3s, including this. We have finished all the 1 and 3s. So now, back to the top corner, right? To top corner, we should find that how many numbers do we remaining? So we remain only 1, 2, and 2, 4, and 3 5s. So how do you fill in it? So first, the 3 5 must in distinct column and distinct row. So the 3 5 can only be written here. As for the 2 4s, right, the 2 4s must be here. And the last 2 is here. So the one number in the corner must be what? Must be 2, right? So, okay, now this is the question. Answer is 2. I don't have the choices, sorry. I don't have the choices, so I just give you the answer. That's all. Then, the second question is to find the pattern of this sequence, which is obviously easy. So you just look at the sequence, you would see that the adjacent number have a similar ratio. The ratio is 3, yeah, close to 3. So it's something that when we compare, if we times the 3, become a 12. Times the 3 becomes a 27. Times 3 becomes a 72. And then if we immediately see what's the pattern. So the last term should be 3 times of the first term, then minus an additional 3, right? So now we just calculated it one by one, but yeah, there may be some miscalculation, I believe. So not that easy to calculate. So calculator, I borrow a calculator to ensure I'm doing correct. So now this one, x is 3 times minus 3, so it's 1824. And y is 1824 times 3 minus 3. So it's 5469, right? So now the sum of them must be 7293. Okay. Yeah. Okay, easy. So the question. So this one is difficult, right? So this one is difficult. Is there no 4 starting in mind? So the pattern is the same. So I don't have the actual paper, right? So this is just the memorized version. Okay. So question 3 is quite difficult. So it says that we have x plus y over z equal to 15. And y plus x over z equal to 20. So x, y, z, they are all whole numbers, right? X, y, z are whole numbers. So we want to find the value of x plus y over z. So actually we can get x, y, and z all together. So how to do this? So I will show you my way. So firstly, we make the fraction into an equation. So we times the z to each side. So we have xz plus y equal to 15z and yz plus x equal to 20z. Okay, so now, yeah, the answer 5 is correct. 5 is correct. So, but for now, how do we solve the x, y, z? So compare with the first and the second equation. So we have x, z, y, z, and x. So maybe we just add them up, right? We just add them up. Yeah, we have a live stream. Oh, yeah, I let someone to share with it. 3. Okay, continue. So we should see for this similar equation, it's very likely to just adding them together or get a difference from each other. So we can use both. So first, we adding them together. So now we should get, so it's x plus y times z plus 1 equal to 35z. And also, we can use the 2 minus 1 again, right? So we should get this yz minus y plus x minus xz. So it can be written as y minus x times z minus 1 equal to 5z. Okay with this? Okay with this? And then we should see that, so now we compare with this. So we have z plus 1, z, z minus 1, z. So I have mentioned before, this is a very important thing for co-prime numbers. So we must know that for two adjacent numbers, they are co-prime, which means z and z plus 1 are co-prime. Z and z minus 1 are also co-prime. And then we will see that, so we should see z plus 1 is the factor of 35z, but z and z plus 1, they are co-prime, which means z plus 1 is a factor of 35. And z minus 1 is a factor of 5z. Z minus 1 is co-prime with z, so z minus 1 should be a factor of 5. That means, so z minus 1 can only be what? Can only be 5. So now z, this is a 5, then z is a 6, z plus 1 is a 7. Just finish it, right? Just finish it, right? So then the only solution for it is z minus 1 equal to 5, z plus 1 equal to 7, z equal to 6. But then we get the z. So after we get the z, everything is easy, right? So everything is easy. So then this is 3, this is 4. So then for 3, it will become, so x plus y, so this is 7 times x plus y equal to 35 times 6. And then 4 will be 5 times y minus x equal to 5 times 6. So then we get x plus y is 30, y minus x is 6. And then we get, yeah, x equal to 12, y equal to 18. So the answer for the x plus y over z, so it's 30 over 6. So the answer is 5, right? Yeah, this is a rather difficult one. Question 4 is easy. Question 4 is easy. So it says that, so A and B, they have 2 times meeting, but they're meeting at the same point. So you know which part determine the position. Yeah, which part determine the position of the meeting point. So the meeting point determines the speed ratio of each other, right? So now we should know that they have the same midpoint, meaning that they should have the same speed ratio. Okay, and then we should see that originally A increased by 50%, And if you want to keep the speed ratio unchanged, so B must increase by 50% as well. And we know B increased by what? Increased by 12 kilometers per hour. So this 12 kilometers per hour is just the 50% of his original speed. So the original speed is 12 divided by this 50%. The answer is 80. Yeah, quite easy one, right? Quite easy one. So maybe I give you some mark. So if this is an easy one, so I mark it an easy. So if it's a difficult one, I mark it a difficult. So this is an easy one. This is a difficult one. This is an easy one. The first question may be just a normal one. Yeah. So I will mark difficulty for you. So easy, normal, difficult. Okay. So for easy question, I expect all of you to answer correctly. So for normal question, yeah, maybe just half-half. And so if it's the difficult question, so if you fail it, it's okay. If you fail a difficult question, it's okay. Right? Question 5, easy question. So we emphasize it again and again and again, even in Sunday, right? Even in Sunday's last examiner, we emphasize this, the fraction splitting terms. So actually, we just turn it into 1 times 3, 3 times 5, 5 times 7, and 20, 23, 20, 25, and then makes the numerator into the difference of the denominator. N times a half to make it even. So now the first is that 1 minus 1 over third, 1 over third minus 1 over 5. Okay, it's just 1 minus 1 over 25. So it's 1012, 2025. So I don't know. So it's choosing for what? So it's choosing for the sum of digits, something like that, right? So yeah, I don't know the actual question. Yeah, there's actual question here. So sum of digits of numerator and denominator, right? So it's what? So new sum of digits of the numerator is 4. It's 9, right? 8, 15. Okay, easy one. So for my student, if one of my students fail on this question, see, maybe you buy me something when you come to me this week. Buy me something. Okay. So question 6 is a very this is a normal question or maybe a difficult question. I have to say. I just say normal. So it says that we have 12 points on a circle, and we should choose 3 of them to make a triangle. So the question is, how many different triangles can be made? So notice that rotation and reflection considered as the same, which means we just want to determine the different shape of triangle. Right? So we just want to determine the different shape of the triangles. Then that's it. Okay? So now, how to determine a shape of a triangle? So maybe we just connect the random 3 points. So maybe like this. Yeah, maybe here. Okay. So we just connect 3 random points to make a triangle. So actually, the 3 sides of length is determined by the distance of the point, maybe on the circle. So we should see that for A, B, and C. So A, B have 1, 2, 3, 4. Distance is 4. So B is 1, 2, 3. Distance is 3. So you know this distance is not the side length of a triangle. Okay. So this is a distance on the circle, right? Distance on the circle. So maybe I just mark it outside. Yeah. No. Damn. I just right here. So there's 1, 2, 3, 4, 5. Okay. There's 3, 4, and 5. And we should know that for all A, B, B, C, and C, we come back to the starting point A, which means the 3 distance, 3, we make it a circular distance. So the sum of the 3 circular distance will equal to the 12, right? So actually, as long as one triangle, right? As long as the triangle shares the same circular distance, they will share the same shape. So just want to determine, so how many distinct ways, so actually, so the shape of triangle just equal to the ways to separate in 12 into 3. So now, should we avoid the crossover, right? So the repetition. So how to do it? So if we want to split the 12, so we just make sure that for 3 numbers we write, so each number is no smaller than the former one, then we'll be okay. So we start with 1. The smallest is 1, 1, 10, 1, 2, 9, 1, 3, 8, 1, 4, 7, 1, 5, 6. And stop here, right? So because if you make a 1, 6, 5, it's overtake. So the third, the 12, the second is overtake third, so which is not possible. So it's a repetition. So now, then we start with 2. So we start with 2, 2, 8, 2, 3, 7, 2, 4, 6, and 2, 5, 5. Then move to 3. So it's 3, 3, 6, 3, 4, 5. Nothing more. And then it's 4, 4, 4. So in total, how many of it? Check. 5, 4, 9, 9, 3. So totally 12. So we have 12 different shapes of triangles. The answer is 12. So this is, so what do you think? Is it a normal question or difficult question? It's obviously not an easy question because you should think of the corresponding of triangles and number separation, right? Maybe a normal one. Yeah, maybe mark it a normal one. Not that difficult, I have to say. 2 plus 3 plus 7. What is 2 plus 3 plus 7? I don't get the question. How to get 2 plus 3 plus 7? You mean how do you draw this triangle? See? 2, 1, 2, 3, 7. Yeah, this is your 2 plus 3 plus 7. So you should know, right? So you should know the distance here is not this not a side length. So this is not a side length. It's the distance on the circle. Yeah, you see, this purple triangle is the 2, 3, and 7. Okay with that, Lucas? Yeah, I have so many lags, so I lag for maybe half a minute. So sorry for that. So maybe I cannot wait for your answer. So let's move on. So my lag for the chat box is half a minute. So long. And for question 7, it's an easy question. We just trained this question right before, right? So last week, so my student, you should remember. So we just trained this question last week. So it's just a typical division of a associated right angle triangle. So we know the left square and we should try the right square. So we should see that. So now the left square have a 1, 2, 6, which means if we divide the figure like that, so each triangle is 63, 63, 63, 63. So the triangle ABJ have an area of 4 times of 63, so which is a 252. And so will be the ACJ because they are identical. And then for the right part, we also do the division. We divide this figure this way. So now this is U. So we have 9 U's to form the ACJ. So now U will be equal to 252 divided by 9, so which is 2 and 8, 28, yeah, 28. And then the square is made by 4U, so the MNOP is 28 times 4, which is 112. Yeah, this is 112. Okay, yeah, easy for that. So this is a very typical 8 to 9 model, right? So for this, Associated right angle triangle, these two squares have a ratio of 8 to 9. Very typical one. Okay, so now this is an easy one also, right? So this question both occurs in our RMPWC long-term course and our P5CO long-term course in the Pythagorean and hypotenuse diagram. You recall about this, right? So my student should be of this. So will Belinda student, right? So if you're studying with me or Bell or Turner, right? So you should recall this question very clearly. So we just moving the segment here to form a right angle triangle this way. So we move the 5 and 3 and 2's here. So AH would equal to 5, 3, and 2. It's a 10. And BH is 1 and 1. It's a 2. Then AB here, we use the Pythagorean theorem. So AB squared equal to AH squared plus BH squared. So which makes 10 squared and 2 squared. So 104, right? So AB squared is 104. And the area of square will equal to half of the AB squared, which will be 52. Easy one. Okay. Okay, move on. Yeah, I should open the, so sorry, my WeChat dropped. Okay, question 9. So you should remember this is the same question on our RMO booklet A. Exactly the same. Not even change your letter, don't even change your word. Remember that? If you remember this question, you type 1. Oh, sad for that. It's not 76, it's 75. It's 75. Very sad for you. No, if you have the 75, it's okay, but it's, yeah. But if you have the 76, I cannot save you. Yeah. Okay. Yeah. So now, yeah, if you, so you know, if you did the question, so you will feel very free to get a point. But if you don't see this question before, it will be difficult for you because, right? So actually, we want to see how many distinct values are there, right? How many distinct values are there? So the key point is actually to find, so which value is distinct, which value is the same. So we compare with these two. So it's 1, 2, 2n, and n's factorial, and 1, 2 to the n plus 1, and n plus 1's factorial. We compare with these two. So how can they be the same? So we transform the first into, right? So we times the n plus 1 to both the numerator and the denominator. So the denominator would become in the n plus 1 factorial. And this is the n plus 1 times 1 to 2n. And then this part, same denominator and the numerator, 1 to n plus 1's LCM is 1 to n's LCM with n plus 1 to find another LCM. Okay, so as long as, right? So as long as these two are equal, right? So how to make this n plus 1 and times 1 to n and this LCM of 1 to n plus 1 equal. We should know that, so if AB's LCM equal to AB's product, then it means AB, they are coprime, right? So meaning that they are coprime, which means if we want to make them be equal, right? So if they are equal, then they must be coprime. So is that, so if n plus 1 and 1 to n's LCM are co-prime, then it's equal. So how to make this equal? So which means, so if n plus 1 is co-prime with all the smaller numbers with it, so then n plus 1 must be a prime number. So as long as n plus 1 is a prime number, you would have the same value as before. Otherwise, right? Otherwise, not equal. So we should know that if one number is prime number, then the value of the term is same as before. Otherwise, it's not same. Which means, so how many prime numbers are there? So among 2 to 100, we have 25 prime numbers. But we should know that 2 is in front. So 2 is a distinct one, right? So except for 2. So other 24 are same as before. So totally we have 99 numbers and 24 of them have the same value as before. So for the other 75, they should have a distinct value. So we have 75 distinct values. Quite obvious. But yeah, it should be a difficult question if you didn't see it. But it must be a very easy question if you did in our bouquet from our Think Academy. Okay, move on. We spent some lot of time on this question. It's difficult, I have to say, but yeah, for you, just sharing the point. The question 10 is easy. We practiced before, right? So it's quite easy. So for an addition of a fraction, the first thing is that we always, right? So we always gather those with the same denominator together because unify the denominator is very difficult for us. So now for this one, we just turn for all numbers with the same denominator, for 3's, for 4's, and till the end is for 30. 31. Okay. Then we adding them together, we would see that in each bracket is a Gaussian sum, right? It's a Gaussian sum. So it's half, and this is half times 3. This is a plus. And this is 2 times 3. And this half times 3 times 4. And the last term is half times 31. 1 to 30 is 30 times 31. So we cancel, right? Those remaining should be 1 over 2, 2 over 2, 3 over 2, and 30 over 2. Then we use the Gaussian sum again, right? So we use the Gaussian sum again. So it's half of the 30 times 31. So then it should be like this. Then what should the final answer? Yeah, it's 232.5, something like that. Right. Easy one, right? Easy one. Question 11, again, an easy one. This is a very typical swallowtail model. We practice it lot of times, especially for our P5 still student, right? Our P5 still student must have done this question just last week. Okay, right? So if you fail on this question, me, Teacher Bell, Teacher Turner, right? So we would be very frustrating, you know. Yeah. So as long as you see this figure, you should connect CF. Then we divide this figure into 3 triangles, which is ABF, ACF, and BCF. So we just use the condition to get the ratio of the 3 triangles here. So first is that ABF to, so this is 3 to 4. Yeah, 3 to 4 and 1 to 1, right? So first, ABF and ACF, yeah, I write it here. So ABF to ACF, this is the external ratio of the swallowtail. So we can just directly get into it into BD over CD, which is 3 to 4. So 3 units, 4 units. And then, so for ABF, ACF, the other, we know AF to DF. How to use AF to DF? Maybe, yeah, we just use, so this is the inside ratio, interior ratio. For interior ratio, we can get the swallowtail triangle BCF to the total ABC. So now we would see BCF over ABC. Now, the common bottom is BC. So the ratio is the vertex to the intersection point. So BCF to ABC is F to D over A to D, which is 1 over 2. So now we can get BCF to ABC is a 1 over 2. Then we unify the unit. How to do this? BCF is 1, ABC is 2, which means the remaining ABF, ACF together is a 1. So then we unify it into a 7. So it's 3, 4, and we unify it into, so this is 7. So this is 7 and 14. So actually, we get the area ratio of each of the 3 triangles. Then let's see what the question is asking for. It said the shaded region is 30 centimeters. So how to get the shaded region? So for example, first we have the BDF. BDF is easy because BDF we can use the BCF to use it. So it's BCF then times, yeah, they have the same bottom, the same height model. So BC is 7 and BD is 3. So it's times 3 over 7. So BCF itself, right? So make this is a 1 unit. So this is a 1 over 2 unit. And then this would be 2 over 7 unit. And this is 3 over 14 unit, right? So now this would be 3 over 14u. And for the AEF, on the other hand, so AEF, we can use, right? We can use the ACF times the AE over AC. But how to get AE over AC? Maybe we get AE over CE first, because according to the swallowtail model, AE over CE equal to ABF and BCF, which is exactly ABF is a 3, BCF is a 7, it's 3 to 7, so it's 3 and 7 here. So now we would see, right? So AE to AC then is 7 to 10, right? So it should be this one times 3 over 10, then it's 3 over 35u. Then making together, the shaded region is 3 over 14 plus 3 over 35, so which is 10, which one? So it's 3 over 10, right? So actually it's 3 over 10 u and equal to 30. So then u equal to 100. Yeah, very easy swallowtail model. So I expect all of you to do it. Then question 12 may be easy or maybe normal. Yeah, I believe it's an easy one. So as long as you see, right, it's a remainder per term problem. 11 is not so large, so maybe you just try to get it. So A1, A2, A3, A4, A5, A6, A7, A8, A9, A10. You just need to calculate each remainder of 7 to the power of n. So for the first term is 7. So I believe the question gives you the first 3 terms, I remember. So it's 7, 5, and 2. So just not in my question because I'm lazy. Because I'm lazy, right? So now it's plot times 7 and times 7. So 2 times 7 is 14, so it's a 3. Then it's a 21, it's a 10. 10 referring to the -1. So as long as we see a -1, we know it's half a per term. As long as we see 1, we know this is a per term. So then this is a 4. This is an 6. This is a 9. This is an 8. And this is a 1. So we see a 1, we know the remainder per term, right? So the remainder per term is 10. Right? The remainder per term is 10. Then, yeah. So the sum to A1 to A20, so 2024 divided by 10 is 202 remainder 4, which means we have 202 whole patterns and the 4 remaining. So the sum would be this 202. You should notice that in the whole term, the remainder is just 1 to 10 respectively. So the sum of each term is 55. And then plus the remainder 4 is the first 4 term is 7, 5, 2, and 3. So which makes it to be like, yeah, calculator again. So yeah, I just say this question, this paper is not that difficult, but the calculation is heavy. Yeah, I mean the calculation is rather heavy. You see, we have this one, no, not this one. Yeah, we have what? Yeah, I recall there are some heavy calculation, but yeah, this one, that's question 2. And then we have the question golf, right? Right. Okay, for question 13. Okay, I have to say, my answer may not be correct for question 13. I always hate this type of question. So it's something like, so not counting. Counting is okay, but this is something like the enumeration. It's just the pure enumeration. And also, right, so if you don't give me the actual answer, so I'm not sure I'm correct. Okay, so it says that how many segments are there? So pass through exactly 3 dots. So there should be exactly 3 dots. Yeah, the question description may not be accurate. So I just adjust it in my understanding, okay? So how to make a line that pass through the segment that pass through exactly 3 points? So it's easy to find out that maybe we just choose this one, right? This one or this one. So the first type is easy to figure. So the type 1 is for those segments on the sides of the equilateral triangle. So parallel to it, right? So then the 3 directions, they're the same. So we just count 1 direction of it. So let's see. So in 1 direction, we have 1, 2, 3, right? So in 1 direction, we have 1, 2, 3, 4, 5, right? In 1 direction. And we have 3 directions here, here, and there. So times additional 3. So which will lead to a 45. So basically, we should get this 45. Is that more? Of course, right? So we may have such a segment such like this, right? Such like this. Or something like, I will draw a picture for you like this, right? So we should have something like this and this. So what's in common, right? So what's in common of this segment? So we must see that, so this segment, so this is a type 2. So how to identify this type 2? The type 2 is that, so we want to form this. This one must be a diagonal. This one must be a diagonal of a parallelogram. So you see. This or this. So if this line is not a side of a square, so it must be a diagonal, right? So it must be a diagonal of an parallelogram. So now we determine, so in a 2 times, so this is called a diagonal of parallelogram. So to form a parallelogram that through exactly 3 points, so there must be one side of parallelogram being 2. So in a 2 times 2, right? So in a 2 times 2 parallelogram, so we have 1. So 1 in 2 times 2 parallelogram. So anything else? Also, right, we can extend it to 2 times 4 parallelogram. Like this. Like this, right? So actually, right, so we have 1 in each, yeah, maybe not maybe I use the each. Two times 4 parallelogram. Three times 3? No, by 2 times 2, I mean the side length. Yeah, I mean the side length. So the side length is 2 times 2. Not the vertex. Not the vertex. Yeah. So now, yeah, for this one, right, first we should find how many 2 times 2 parallelograms are there. So of course, parallelogram also have 3 directions. So it's this direction, and this direction, right? So yeah, I believe we have a question in either Nemo's book B or RMO book A, right? So we just count at one direction, say this direction, right? So how many of the 2 times 2s are there? So maybe it's, so we compare with the smallest one. This is 1, and then 2, 3, and then 4, 5, 6, right? So we have 6 parallelogram in each direction, and we have 3 directions, and each parallelogram has a 1. So in total, we have 18, right? In total, we have 18. And for the 2 times 4 parallelogram, however, so for 2 times 4 parallelogram, it's not that easy to find. So maybe just draw 4 here. 1, 2, 3, 4. Yeah, here. So for this one, so how many are there? So 1, right? And 2. This is 2. And then to this side, right? So to the other side, yeah. So this is 1, 2. And also for this side, it's an 3. Yeah, that's 3. 2 times 4, 2 times 4. So how to get a 2 times 4? Yeah, this is 3. Yeah, 3 and 4, right? So 1, 2, 3, 4, 5, 6. We should have 6 in each direction. Sorry, we have 2 in each direction, and we have 3 directions. So totally, actually, we have what? We have 6, right? So we have 6. So it's 3 times, so 6. And each of it contains 1. So we have 6 diagonals. So making together is 45, 18, and 6. So it's, how many of it? 69, right? Yeah. But I'm not sure. But I'm not sure if this is the correct answer, you know? So I don't see the correct answer. I don't see the official answer. So this is what I can count. So I'm not sure if there is more, some weirder shape. Yeah, some weirder shape. So my answer is 69, but some of my students tells me that there is no choice for 69. So it's either that I'm wrong, so you should choose the E. So either I'm correct, you choose the E, or either I'm wrong, you choose a larger number than 69. So I believe the only number larger than 69 is what, 72? Maybe, yeah, I don't know. So for this question, it's the only question I, myself, is not sure about the answer. Okay. So you can blame me on that. But yeah, actually, maybe I will do the correction afterwards. So I will tell you, yeah, sorry, I find something more. Maybe, yeah. But never mind. So this is, yeah. The only choice of 68, yeah. Never mind. So we have done all the C. We have calculated 69. So the answer must be no less than 69. So never mind, forget it. Okay. I hate this type of question. So there's no, so the skill. So I have already given you the skills of it. So you can follow my way to get the answer, but it's that I'm not sure is there any other hidden. So for example, if there is another direction of diagonal. So I feel no, but I'm not so sure, right? So I only have 80%, yeah, confident of this question. For all the other questions is 100%. Okay. Then we move to the question 14. Yeah, question 14 is a difficult one. I have to say, yeah, difficult. Yeah, difficult because the choice will not help you. The choice just give you the sum, so will not be that helpful. Or unless, because you can prove, right? So in some case, you can prove the sum of it must be a multiple of 12 or something like that. So that's just Belinda, right? Just Belinda did the question, and he finished this question quicker than me, and she told me that she used a method that she just tried to prove, right? So the answer is a multiple of 12, and then she told me that the only choice is 48, so they choose 48. So I don't know. So if the choice can help, then never mind. So I believe it's a difficult question. So actually, the logic is like that. So Alice gave Charlie 20, but it's E. It's E. So the choice will not be helpful. Or maybe all the choice is not a multiple 12, then choose E. Yeah, maybe. Yeah, and never mind. So now it says that, so we name Alice to be X, Bob to be Y, Charlie to be Z. So Alice gives Charlie 20 marbles. So Charlie is 2 times than Alice and Bob. So it's Charlie have 20, then will be 2 times of Alice and Bob. Also, right, so Alice gave Bob 30, so Bob gets 30 will be 3 times of Alice and Charlie. So we have 3 unknown terms, but only 2 equations. So this is yeah, choose 54, 60, something, none, right? So yeah, maybe, yeah, then this method never worked, right? So you may choose 60, or you prove 60 impossible, then you choose none of above. Yeah, never mind. So I will show you the actual way to do it. I will show you how to do it. So now first, right? So we makes it, yeah, into a simplest form. So it would get to something like, so the first form is something 2x plus 2y minus z equal to 60. And then the 3x plus 3z minus y equal to CD 120. Right. So now we have 3, it's an indeterminate equation, but it's 3 variable, 2 equations. So now, so the key point is we should cancel one of the variables. So cancel who? So cancel y and z, both are okay, but don't cancel x. Why? Because we should use x to solve the problem. So maybe we cancel y here. So y, no, maybe we cancel z here. Maybe we cancel z here. So if you want to cancel z, then it's 1 times 3, then plus 2 to cancel the z. Then we should get, so we have 6 and 6, 3. So 9x plus, and here would be 2 times 3, 6, 6 minus 1, 5. So 9x plus 5y, so equal to 300, right? So we have 9x plus 5y equal to 300. So yeah, this is Taylor's parent. Yeah, I believe. So now Alice has 25, Bob has 15, Charlie has 20. So this is a wrong answer. Do you know why this is a wrong answer? Because, right, you can get the solution from this equation. It's all okay. But there is a hidden limitation. Yeah, this is the difficult part of this question. What is the limitation? Read this sentence. If Alice gave Bob 30 marbles. So if Alice is able to give out 30 marbles, which means Alice must have at least 30 marbles. So your solution, 25, 50, 20 is okay, but it missed this hidden limitation. Set for that? Yeah. No, it can be equal to 30. Can be equal to 30. Actually, it can only be equal to 30, actually. So now we look at this. So x is over 30, and also 9x plus 5y is 300. So the only solution may be just equal to 30 because x must be because this is multiple 5. So x must be multiple 5. So the only one is the 30 and 6. The only solution is x equal to 30, y equal to then 6. Then we get back to for the z, right? So we get back to the z. Meanwhile, we get back to the z to get the value of z. So z is a 12, right? Z is a 12. Okay. The key point is this hidden limitation, which is quite hidden. Yeah, you should notice that. So all the question will have so many solutions, maybe infinite solutions, or maybe finite. It must be finite, but not that finite. So maybe have 3, 4, or 5 group of different solutions actually, right? So the sum is 48. So that's a difficult question. That's a difficult question. Okay. Question 15, then question 15. So 3 bottles of juice with same volume. So it's just, we just unify the unit by this PSLE one. Yeah, this is the PSLE level question. So the water to fruit is 2 to 1, 4 to 3, 7 to 5 respectively. And then, so because they have the same volume, so which is the constant total. So we just name the total here. We mark the total. So it's 3, 7, and 12. And we should unify it because the total is the same. We unify the unit by the totals. So 3, 7, and 12. So which number should we choose? Which number should we choose? Which number should we choose? 48, right? Sorry, 84. Yeah, 84, 84, and 84. So now we make it into 28, 56. So this is 36, 48. And this is 35. And so what's that? And what's it? So it's a 49. Yeah, 49. Yeah. So then we just adding them together. So we unify, the unit is unified, and we adding them together. So this is what? This is 153. This is a 99. So obviously we can cancel the 9 here. We cancel the 9 here to make it 17 to 11. It's 17 to 11 or 11 to 17. I don't know. Yeah. 17 to 11 maybe. Okay. And then for question 16, n consecutive natural numbers adding up to 2024. So I mentioned you before, right, in the Sunday. I told you this is some must-knows about arithmetic sum, right? Break one number into arithmetic sum. So actually, so if we assume 2024, it should be, I don't know, a normal one. Yeah, normal one. So 2024 equal to 80 plus 1, n terms, right? n0 plus 2, n0 plus n minus 1, not n. And then we would see that we use the Gaussian sum for it to get half of the m of the 280 plus n minus 1. Then V is 4048 is n times 280 plus n minus 1, right? So now 4048, so we should be familiar with 2024 is 2 to the power of 3 and 11 and 23. So we added 2, so it's and so it's 11 and 23, right? 253, no. If we want to separate into 253 numbers, so they must be minus numbers here. They must be minus numbers here. So you see from that. So now how do we tell the maximum value of n? So we have two conditions to follow. One is that n, because a0 is at least 1, so n must be smaller than another factor, right? So n must be the smaller factor. So if you make n to be 253, then the other is a 16, which is not correct. So a0 must be a minus number, a negative number. No, so no, right? Secondly, we should notice that these two numbers, they must have this different parity. So n and 280 plus n minus 1 have different parity. Parities, actually. So it's one odd and one even, which means this 2 to the power 4, we can put it on either side together. So now the point is, so if we want to make n to be even, right? If n is even, then n must be something 16, right? And that's a 253. Yeah, this is okay, but if you make n larger, for example, 16 times 11, no, right? It overtake the 2an plus n minus 1. So not good for this. So now so the first possible, if n is even, is that. And then if n is odd, then at last, so the largest n can only be 23, right? 11 is small, 23 is okay, but if it is 253, right, it's overtake 280 plus n minus 1, so a0 must be a minus number, right? So now the odd number is 23, and this is 176. So of course, this one is larger, right? So the largest possible n, right? So the largest possible n is 23. Should be a normal one, right? So we run through this question, we practice question a lot and a lot. So I suppose our student can finish it easily. Okay. Yeah, question 17. So a very easy pigeonhole theorem problem. So yeah, have I talked to you about this question before? Oh my God. Yeah. So at least I did in my Sunday class. Yeah, at least I run through this question quite often in my Sunday class. So I don't know. I don't remember from my normal class, did you run through the pigeonhole theorem? Yeah, I believe so. I believe so. At least in our long-term course, we have such a thing, right? For P6. I don't know if for P5 we run through this, but never mind. So P5, we left something. Yeah, it's okay. So now it's just that we want to ensure the two numbers sum is 20. So maybe we just classify the numbers or group them into, actually, we have 10 pigeonholes. That is 119, 218, 317 to 911, and then a solo 10. So it's very easy, right? So as long as we choose, we have 10 pigeonholes. We want to ensure two numbers from the one pigeonhole is 10 plus 1. So we have 11 to be chosen. Right? Very easy one. So the answer is 10. Yeah. Okay, yeah, you can choose 1 to 10 is not okay, and then plus 1. Yeah, it's very easy one. Question 18. In school band 13 more. Yeah, this is a new question. So I haven't seen the question before I opened the examiner, right? So this is the new updated version, the question 18. So yeah, let me see the question. So 30 more boys and girls. So in 2023, 2024, so the number of boys is increased by, yeah, maybe we use the algebra to solve it easier. Boys and girls. So boys is a U. Yeah, sorry, girls is a U. Boys is U plus 30. So the total is 2U plus 30. And then the boy increased by 5%. So it's 1U plus 30. And girl is increased by 20, 1.2U. The total is 2U. Yeah, total increase by how many? 10%. So 1.2U plus 30. And then we adding them to make the total. Then okay. Yeah, algebra is okay. So it's easy to use the algebra, I believe. So 05U, and this is what? So this is so can we just times 100 here to make it easier? So it's, yeah, quite easier. So how many U's are there? So 220, this is in 205, yeah, 225. So 5U will equal to, oh no. So it's calculator. Oh no. Yeah, 150. Right. So U equal to 30. Yeah, HU equal to 30. Okay. Okay. Then what was the question again? So how many members were there in the 2023? So it's 2 times 30 plus 30 is 90. It's 90. Am I correct? Calculate correctly? Yeah, I believe so. I believe so. Yeah. Okay. Okay, now this is all the 18 questions I have got. So I know there is an angle calculation, but I don't see the figure, and I don't expect you can draw a figure in the chat box. So let me see the WeChat group and WhatsApp group. So if anyone shares the angle problem, anyone shares the, yeah, can anyone share me the angle problem in the, yeah, no for WeChat group, what's about WhatsApp group? So who knows the angle question? The only missing is, yeah. So, and we have a last question except for the angle question. Yeah, the answer, it's no meaning if I know the answer is 164. Yeah, it's hard to draw. So yeah, never mind, never mind, never mind. So, and the last one. So what's the last one except for the angle? Yeah, what is the last one except for the angle? I can, yeah, maybe someone may try to draw the angles for me. What's the last question except for the angle? Okay, that's the only two question missing. I don't know. Yeah, we can wait here. We can wait here. Never mind. So we have a lot of time today, right? So we don't have another test to prepare. Yeah, actually we have the smokes. Actually, we can remember the line. Yeah, okay. Thanks for 许多. Yeah, we get the missing question. So Turner, take your note. So it's 8. Yeah, I quoted here. So it's how many digits are to 2024? How many digits are there? Okay, we solved this one. Yeah, we solved this one. Okay, so now this is what the page problem, digit problem, right? So now we should just classify the number by the number of digits they are. So now first is that, so for one digit, only one. So 1 times 1. For two digits, so it's 8 times 2 to 8 times 12, right? So we have 11. So, and there's 11 times 2. So for three digits, so it's 8 times 13 to 8 times 124, because 8 times 125 is 1,000, the four-digit number. So how many are there? So it's 112. So 112 times 3. So others are four digits. So 8 times 125 to about this 8 times 253. Yeah, 2024, right? So now so how many are there? So it's 129. So 129 times 4. Make the calculator. Okay. Okay, I wait for your angles. Okay. Okay, we have only one question remaining. Is the angles. Yeah, we wait for angles. So meanwhile, yeah, let's chat. Yeah. So how many questions did you get correctly? Yeah. So how many questions did you get correctly? Yeah, this is an easy question, by the way. This is an easy question. The question has arrows in the test. There is no 24. Is there no 24? Really? I don't know. Yes. Someone tell me there's no 24, but yeah, I can't see the question. I can't see the question. Only you can. What do you recall? Do we have 24? I don't know. If there is no, yeah, if there is 24. Yeah, okay. Okay, then never mind. Okay, we have the angles, but how can we draw the picture here? So how can we draw the picture here? So you send me, yeah. Did you send me on my WeChat? Yeah. Okay. And so how do we quote it? Never mind, draw it. Never mind, draw it. Yeah, wait me for a while to draw the picture. Okay. Okay. So it's 56 degree here. Yeah, sorry. 40 degree here. And we want to find the angle of CDEFG. Yeah, I know what the question is asking for. I see the picture, I will know the question was asking for, right? So find CDEFG. Okay, this is the last question from examiner. Actually, yes. Yeah, actually, yes. So now, how to solve this question? So I will show you a way. So you can use many methods to solve it, but I will show you a very interesting way. The interesting way is called the working method. So to calculate these angles, we have the working method, a very interesting one. So it's suitable for the end for today. So we imagine there is a people here. There's a small guy here. Okay, there's a small guy here, and start walking from this A, and he walks along the side of the stars. So it's this one, and then here, and then here, 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 and okay. So we treat it like a one guy, right, walking along this round. So I have a question for you. So when this guy finished the whole round, so how many whole circle did he turn? So if so, for example, right? So yeah, how do I demonstrate it for you? So now he walked from A to D, right? Then he makes turns. Then move to G, makes a turn. And from C makes another turn, right? So we should see that. So if you are this guy, it's easy to imagine that at the C, you will finish your first round, right? You already turned for 360 degrees, right? You already turned for 360 degrees. So this is angle 1, angle 2, angle 3. And then for this E, right, you make turns, angle 4. And then, so for this one, right, so now for this one, it's very, so you should turn what? You should turn clockwise or anti-clockwise. Yeah, you should turn this one, right? So you turn this one, and then, so, no, yeah, sorry. So, yeah, it's wrong of the battery. So, and then, so for this one, you make this round, back to normal, and then back to normal. You would see that in this case, right? So here you make your second turn, right? Here you make your second turn, and here, finally, you made your third turn. So actually, if we walk around the whole figure, right? So one round, yeah, sorry, it's that one period. When you back to the normal, it will take you 3 rounds to turn, right? So you turn 3 rounds of 360 degrees. And so the total angle of turning, which be 1, 2, 3, 4, 5, right? No, this is not 4. So this one must be the 4, actually. Oh, no. Yeah, it's correct. It's correct. So this one is the 4. 1, 2, 3, 4, 5, 6, 7. So it's 5, 6, 7, right? So you would see that angle 1 to angle 7 is what? You make 3 times 360. And then, however, if you want to calculate the angle A to angle G, right? So because, right, so this angle here, right, is the exterior angle of this point. So it's A is 180 minus 1, B is 180 minus 2. And so far is 180 minus 7. So the sum of A to G will be 7 of 180 minus 3 of the 360, right? How do you know that it is 360 degrees? What do you mean? So what do you mean by how do I know the angle is 360? Because, yeah, if we want to make a turn, so, if you want to make a turn, you must turn 360 degrees to reach your point, actually. So if we want to make a turn, if you turn back to your direction, to your original direction, you must turn for 360 degrees. Are you okay with that? Are you okay with this? I mean, so I don't know. So are you okay with this? Yeah, the turn is 360 degrees because if you make a turn, if you make a turn, so you don't understand why. So now you are facing this direction, right? And then you make turns. And eventually, when you back to this direction, how many degrees did you rotate? You must rotate for 360 degrees. You must rotate 360 degrees to come back to your normal direction, right? Okay with that? Okay with that? Okay with that? So now, the first time you turn back the direction is here, right? So here is the first time you turn back to your former direction. So this is when you make the first turn. And then it's here, then here, and then following here, and then turning here. Oh, no. You remind me something is that, so the angle of turning is the opposite side. So for this angle 5, it's not correct. So because, right, if you turn this way, this is something that oppose, right? So actually, this is something that oppose this is anti-clockwise, but we always turn clockwise. So we don't measure this angle like this. So we measure the angle like this. Yeah. So something different from here. So this angle should be measured this way. Yeah. So the angle should be measured this way. So because we should all follow the clockwise instead of anti-clockwise. So yeah, here makes something different. So this is the angle 5, right? This is the angle 5. And this, here, this is when you make the second turning, right? The second 360. And then come back. Back is the third time of turning. So the angle of turning, right? So it's 360. But, right? So you remind me, thank you. Or I will make some mistakes. But I will realize the mistake after doing everything else, right? So actually it's that. So for this angle, the angle 5, right? The turning angle, if we follow the anti-clock, right? It's like this. And then we would see, so now since differs, right? So we may, right? So now it's something like, so for angle A, right? We write it here. So angle A, B, C, D, E, F, G. So it's 1 to 7 is this. So angle A is what? Angle A is 180 minus 7, 180 minus 1, 180 minus 2, 180 minus 3, 180 minus 4. Yeah, sorry, but for B it's not. No. For B it's not. So 1, 2, 3, 4. But for B, you should notice that for this B, right? The key point is that for this B, angle B does not equal to the angle 5 minus, but it's 1. But this is angle 5 minus 180 is the number of, is this one, right? And this is 180 minus the 6, actually. So actually, the sum of A to G, so instead of, right, so instead of see the 7 of 180 minus something, right? So maybe we make B aside, and this A, C to G. So now this, so we know the B, right, is 40 degree plus, or maybe we just can, we don't want this B, right? We don't want this B because we know the B, so we don't want this B. So we just use the A, C, D, E, F, G, okay, to be. So we have 6 of 180 minus angle 1, 2, 3, 4, 6, and 7. So what is this? So 1, 2, 7 is this, and we should know the angle 5. The angle 5 is 180 plus the 40 degree is 220 degree. So angle 1, 2, 3, 4, 6, 7 is minus, see, minus the 220. So then we just use this to minus the A60. So it's 220. So A, C, D, E, F, G is 220. A is what? A is 56. So C, D, E, F, G is 220 minus the 56. The answer is 164 degree. Yeah, 164 degree. Okay, now, yeah, a little bit complicated, right? So why introduce? Because it's fun. Because it's fun. Actually, yeah, I don't like this way, but I think it's fun. So maybe I will share you about it because it's the end of the day. So you are very tired, right? So if you want to do it directly, it's okay. Yeah, it's okay if you want to do it directly. It's that if we don't use this main working method, we just forming all the circles into white triangle to figure it out. I think it's okay. Yeah, I think it's okay. So maybe we just, right? So maybe we just use this one. So how to put all the angle together then? So for example, right, so C and G, so C and G equal to this angle 1 is the exterior angle, right, is the exterior angle. And also, right, so A and D equal to this one. And for B, F, and E, I will choose a relatively concerned angle for it. Yeah, maybe just this. So this is angle 2, right? And this is angle F. And this is angle E. So now we would see, right? So we would see that, so this is C plus G is here. And A plus D is here. And also the A, G, and F. So angle 1 and angle F, sorry, angle 1 and angle E is angle 3. Angle 2 and angle F is angle 4. Now we would see that, so A, B, C, D, yeah, A, C, D, E, F, G together is the two exterior angle of 3 and 4. So A, C, D, E, F, G is 3 and 4. So this is our two exterior angle, right? This is two exterior angles. So we will try to find this exterior angle, 140, right? And we know that the exterior angle sum of a triangle is what? Is 360, right? 360, which means, right? So this one would equal to 360 minus 140, which is 220. Then the same, right? Then the same. Okay. Yeah, it's my network error because, yeah, I see the screen stopped. Can you hear me now? Can you hear me now? Sorry, can you hear me now? It's my network error. Never mind. Yeah. Maybe I have some trouble with the network, but never mind. So I will stay here. Okay. Okay. Yeah, but never mind. So my network has some trouble. So maybe just see here. Okay. So, okay, end of the day. Yeah, thank for you. So I get the missing two questions. So I now get all the questions here. So how many did you get correctly? So yeah, this is say a normal question or easy question. I don't know, maybe easy. So how many easy questions are there in total? Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, 13 maybe. This is a normal question then. 13 question. Yeah, 13 question. 17. So if we have 13 easy questions, so now this year's, so I have to say that which one? This one. So someone said that this question is asking for 2024, not in 2023, but never mind. So yeah, you know how to do it, then it's okay. So it's either 19 or 99. Yeah, I don't know. So I don't ensure the question is correct. Yeah, I don't ensure the question is correct. Very good for you, Yanxiang. If you get 15 correct, very good for you. So I believe 15 will ensure you to second round. But yeah, you are in a junior, right? So Yanxiang, you are in a junior. So I believe it, yeah, very good for you. Yeah, junior is easier than the open. 804. Yeah. Then 99 then. Yeah, this is 104. Then 99 then. Yeah, never mind. Right. So maybe we add in something. Yeah, I don't know. Yeah, I don't ensure the question is correct. I have to say. Yeah, I just ensure the answer is correct. Okay. Yeah, I don't ensure the question. Okay. Yeah. So I believe the estimated high distinction, yeah, for open maybe over 70. Yeah, maybe over 70. This question is not that easy. Over 70. And for junior, I don't know about junior. For junior, maybe just 60, 65. I don't know. Yeah. So the question, yeah, you see so many easy questions. So there are 13 easy questions. 11 over 20, 11 over 20. So it's okay for distinction, but I don't know if you can reach a high distinction. Are you in primary 5 or primary 6? The team or are you in primary 5, primary 6? So primary 5, maybe it's okay to reach a high distinction, but primary 6, I suppose no. So I suppose maybe if 15. $56 can get distinction? I believe so. Yeah, I believe so. Distinction is enough, right? 56 is enough for distinction. So we are talking about a high distinction. Yeah, we are talking about a high distinction. Distinction ranked for the top 15%, so which is quite a large range, you know. So Mary, so yeah, if you get 11 over 20, you are at least a distinction. At least a distinction. 69 get high distinction, Keegan. Yeah, you're in open, so maybe or maybe not. I'm not so sure. So for my estimation, the high distinction is 70. 70. Yeah. 62, of course not. Obviously not. At least 65. At least 65. I don't, yeah. You know, this year is Chinese Dragon's Year. Do you know what the Dragon's Year mean? The Dragon's Year, you are fighting with the dragon boys and girls. The dragon boys and girls are very powerful. Their parents are so stressed on their studies. You know, 78, actually 78 is quite enough. Yeah, 78 is enough for you. And not to mention that you are in a junior group. So you are in junior group instead of open group. Okay. So just maybe the dragon means harder, yeah. Dragon means harder. Okay, maybe enough for today. Yeah, I will send. Yeah, I've already sent this on my 小红书. So for Chinese students, don't forget to cheat. 点赞或关注 on my 小红书. Okay, and then and I will send the written solution into the WhatsApp and WeChat group. So because now this is the full version. So in 小红书, I only have 17 questions. Yeah, I only have 17 questions. Yeah. Okay, thank you for all. And you all did quite well in today's test. Okay. Yeah, have a good rest. Have a good rest. So for my students, yeah, see you tomorrow or see you this week. Okay, bye-bye. How much pass round one? You mean you get round two? 70? 70 or more? Yeah, there's no mark in my paper. Okay, bye guys. Okay, I will end the stream now.